Hi class, welcome to our lesson on 10.4. In this lesson we're talking about common logs. What a common log is it's a logarithmic equation that always has a base 10. They're so commonly used that that's why they got their name, common logs. We don't even write the base. It's kind of like the square root of something. We don't even write the index of 2 right there. It's so common that whenever we see the square root, you just assume that it has a base, that it has an index of 2. Same thing if it's like the log of 7, you assume that it's the log base 10 of 7. That 10 is just assumed to be there. So because it's used so much, there was this book back in the day before we have the technology that we have today where we had all of these different numerical values for base 10 logs. Thankfully for you guys, we have the whole thing stored in our calculator. So we're going to be using that today. So let's just practice really quick. What is the log of 3, or the log base 10 of 3? All we do is push log 3 in our calculator, and we get the answer. So the log button is right next to the 7 log of, number did I say? The log of 3. And we're going to round to 4 decimal places. So 0.4471. 0.4471 is going to be your answer that I require of you on this assignment. So there it is, 0.4771. You could put in the log of 2, and you're going to get this, 0.3010. So knowing that, why in the world does that help us? Well, it helps us to solve exponential equations. I want to know what x is. If I take the log of both sides, in an equation, as long as you do something to one side, you can do it to the other, and it doesn't change the equation at all. I can multiply by the same number on both sides, divide by the same number on both sides. I could take the log of both sides, and I don't change the equation at all. So that's what's happening here. I could take the log base 10 of 3x and the log base 10 of 11, and I haven't changed the equation at all. It's still balanced. And I don't even have to write this base 10 in here, so I could really just write it like this. Log 3 raised to the x equals log of 11. Now I could use the power property, which you learned yesterday, to move this x in front as a coefficient. So now it's multiplied. So it is x multiplied by log 3. You can put a parenthesis right there, equals log of 11. And now if I divide both sides by log 3, that's what this says, log 11 divided by log 3, I could put that into my calculator and get this value. So that is how that helps us. Now I know what x equals. This number right here is 2.1827. You could check that in your calculator, and you're going to get approximately 11. Okay, so let's practice this. I don't know what x is, so let's take the log of both sides. Log 10 raised to the x equals log 2. I should say 2. At first you see if you can get common bases, but there's no way you can get 10 to be a base of 2. So we're stuck there. So now we have to take the log of both sides, which we just did. Now we're going to move this x out in front. So it's x multiplied by the log of 10. That equals the log of 2. So now to get x all by itself, right now it's multiplied by the log of 10, so we get rid of it by dividing by the log of 10, and shoo, that's gone. Divide both sides by the log of 10, and there we have our answer. X is approximately equal to, don't put equals to because it doesn't equal something, it's approximately equal to log 2 divided by log 10. Be careful when you put this in your calculator. It's log 2, close your parenthesis, divided by log 10, close your parenthesis. You will get a wrong answer if you don't close your parenthesis. And round to 4 decimal places. So 0.3010. 0.3010. There's our answer for the first problem. 0.3010. All right, why don't you guys try the second one on your own, please. After you tried this one, hopefully you got x multiplied by the log of 5. That equals the log of 9. So when you divide both sides by log 5, log 9 divided by log 5, you should have got x to be approximately equal to 1.3652. 1.3652. There's the answer for problem number 2. Let's try problem number 3 altogether. Now we have a binomial exponent, but we're going to do the exact same thing. We're going to take the log of both sides. So the log of 3.1 raised to the a minus 3, that equals the log of 9.42. Now what we're going to do is we're going to move this to the front as a coefficient. So it's a minus 3 multiplied by the log of 3.1. Remember, it's a log with a base 10, but we never write that base. That equals the log of 9.42. Let's divide both sides here by the log of 3.1, and that'll take care of that. Divided by the log of 3.1. So I'm going to get a decimal answer. I'm just going to leave it like this for a moment. A minus 3 equals the log of 9.42 divided by the log of 3.1. And then finally, to get a by itself, I'm simply going to add 3. So I take this answer right here and I add 3 to it. And that's what a equals. A equals the log of 9.42 divided by the log of 3.1 plus 3. Let's do that in our calculator, and there's our value for a. So the log of 9.42, log 9.42 divided by, parenthesis, divided by the log of, what was the other one again? 3.1. The log, there we are, the log of 3.1, close parenthesis, equals, and then at the end, we're going to add 3, so plus 3. My value, round to 4 decimal places, 4.9824. 4.9824. There's our answer for that question. Letter A equals 4.9824. Why don't you guys try the next one on your own, please? See what you come up with for problem number 4. So you hopefully did it the same way. You took the log of both sides, and then you brought x plus 4 in front as a coefficient. That equals the log of 2.3. That equals the log of 7.56. So then you divided by the log of 2.3, hopefully. X plus 4 equals the log of 7.56 divided by the log of 2.3. And then at the end, you subtracted 4. So here is your answer, but then when you put that into your calculator, you get x to be approximately equal to, hopefully you got a negative 1.5713. A negative 1.5713. And there's the answer for problem number 4. Okay, problem number 5, it gets one step trickier in difficulty level, I guess. We're still going to take the log of both sides. So log of 6 raised to the x minus 5, that equals the log of 2 raised to the 7x plus 2. Now what we got to do is we're going to use the power property again to move our exponents out in front as a coefficient. So x minus 5 is now multiplied by the log of 6, and that equals 7x plus 2, because we're going to bring this out in front as a coefficient, multiplied by the log of 2. Okay, now we're going to get a little bit messy, okay? So get ready to get your hands dirty. We're going to divide both sides by the log of 6. So now it's gone from this side. And we're going to divide both sides by the log of 6. So now I have x minus 5 by itself on the left, but I have this mess over on the right side of 7x plus 2 multiplied by the log of 2 divided by the log of 6. Let's get this as a 4 decimal answer. Log 2 divided by log 6. So log 2 divided by log 6. And that is, to 4 decimal places, 3.869. 0.3869. 0.3869. 0.869. So as gross of a number as that is, hopefully it's not too difficult from here on out, because all we're going to do now is use the distributive property, distribute, and solve for x. So x minus 5, that equals 7 times 0.3869. And when you do that, so as I distribute, I would get 0.3869 times 7 to be 2.7083x, and then 0.3869 times 2 to be plus 0.7738. So now I'm going to get all my x's together. I'll subtract an x from this side, and I'll subtract 0.7738 from this side to get on this side of the equation. So then, on the right side, I end up with 1.7083x, and on the left side, I end up with a negative 5.7738. So then finally, I got to get x all by itself, so I got to divide by this gross number and do that to both sides. And my solution then is x is approximately equal to a negative 3.3799. Quite a process to get the right answer. Why don't you guys try that one on your own, please? So when you tried this one, you got the log base 3 of 2x plus 3, but then you move that out in front as a coefficient, and then you did the same thing over here. 4x minus 6 moved out front as a coefficient, and then you multiplied it by the log of 7. And then you divided by the log of 3. So that took care of it there. You divided by the log of 3. So then you get 2x plus 3 on the left side. That equals 4x minus 6 times the log of 7 divided by the log of 3, which is the same thing as 1.7712. And then you distributed that, and then you hopefully solved the simple equation. So as you did that, you got x to be approximately equal to 2.6799. 2.6799. Let me know tomorrow if you have any questions on finishing that one out. I trust that you guys can solve that equation on your own, though. The last thing that we have here in this video lesson is the change in base formula. When we don't have a base 10, what we can do is we can make it into a base 10. Right here we have a base of 4, log base 4 of 25, but one property that we can use here is the change of base formula to make log of 25 divided by the log of 4. So it's a very simple process. You basically take the number that's a little bit higher, log of 25, divided by the base, log of 4. So when I said higher, I shouldn't have used that language. I meant you're going to put the base in the denominator, and you're going to put this number in the numerator. So log 25 divided by log 4, and you get 2.3219. So you guys can do these very quickly. This is the same thing as the log of 5 divided by the log of 7. You do that in your calculator. Log 5 divided by log 7. Log 5 divided by log 7. And you get 0.8271. 0.8271. So that's what you should get for that first one. Trying the next two, you get log 13 divided by log 8. When you do that in your calculator, you should get approximately 1.2335. And then for the last one, problem number 3, you should take the log of 3.9 divided by the log of 0.5, and to get that in your calculator, you would get approximately equal to a negative 1.9635. So there's our lesson on common logs. Let me know if you have any questions on that when you get to class tomorrow.